Hello and welcome to Minute MLOps. So that's it, we're almost ready to train our AI, but from the start, we've been rushing things. In other words, we rushed headlong into the code without even asking ourselves whether we were starting with the best solution to meet our needs. And that's what this episode is all about. Come on, let's go. Before starting this type of project, you need to establish a baseline. In other words, at what prediction rate will your IT project start to be useful? Let's take the example of our fictitious project and imagine that in production we always have the same distribution every day, which doesn't vary, and that we have 1% cats, 20% dogs, and 79% others. The baseline is quite simple to match. If you predict something else all the time, we know we'll have a prediction quality of 79%. So if we start building an algorithm that does better than 79%, our project begins to be useful. Now, I'm going to get into a little bit of feedback. The idea is not to criticize anyone. I'm going to explain what it takes to make a project fail, and conversely, what I've learned to get in the way of making it work. Come on, let's go. At the pizzeria, you never see luxury cutlery because it's not adapted to the needs of users. Customer needs. In IT, it's the same thing. Let me give you two examples. The first is this. I worked on a project to automatically read driving licenses in real time. We had a web front end. You could click to upload a file to use it as input to an API call. The API had to respond in less than 10 seconds to bring up the results. That was the user need. What happened was that a data science team worked on this project. When I got the project back and took the first algorithm and put it on a production ISO machine, I realized that there was a problem because the first algorithm, which is the extraction of images, PDFs, was already taking more than 20 seconds. And that's a problem because the customer won't be happy to wait very long for his prediction. What happens is that these things happen all the time. It's logical because when you're on the drive side, you have very powerful machines, which can have 80 cores, 80 gigabytes of RAM, and even GPUs. And we're not aware of this type of problem. And that's the solution to make it work. This kind of thing is to set up what we're setting up here with this show, i.e. MLOps project template, so that from the very first day of the exploration phase, in less than an hour, we'll have a project to train an AI, even a fictitious one, deploy it on an ISO production environment, and produce metrics for training and production, including processing time. That's the solution to this problem. The second little story in relation to user needs is that a little further on in this project, I realized that certain permits were very, very long to read. It clogged up the systems, took more than a minute, and in the end, the prediction wasn't good. When I looked at these documents, I realized that they were basically completely illegible, which means that the customer puts in his coin, waits over a minute to get a result, it's not read, so he's not happy. The solution to this is perhaps to look up and, instead of striving to create the best AI in the world, to read all the documents, if we look up, maybe we'll realize that in terms of UX, in terms of the web interface, we can put some safeguards in place, perhaps to force the user to take a photo, to check the quality of the document, so that we can instantly say to the user, your document is not of good quality. That way the customer won't be surprised, and it's better to tell him right away that the document isn't of good quality than to wait a minute to tell him the document hasn't been read. So really it's important to focus on the user's needs. The second little story is that very often in all IT projects it can be tempting. We've learned to do machine learning, we've learned to do deep learning, so we do everything with it. But what we really need to do is lift our heads and ask the questions. Isn't there a quicker, cheaper way to go into production? You need to know that, for example, with conventional code, you'll iterate faster without implementing all the complexity of a machine learning project. And this also works with today's trendy LLMs. Here's an example from my little driver's license project. Historically, we had algorithms, 5 of them, that would straighten out the images. 5 different algorithms that had to be hosted in production, which took up a lot of RAM and were very slow to run. And we replaced them with simple homography algorithms we found in OpenCV. And we've really saved a lot of seconds in processing time and also in infrastructure hosting costs, and that's no mean feat. So what should we do about it? Always use the right tool for the right job. In general, before you start, try to go beyond the baseline already just with code. In some cases you won't be able to, but sometimes you'll just have to keep at it, because it's not a waste of time. Imagine you have no data for annotations. This might allow you to speed up the annotation phase by already being able to speed up pre-annotations. It might also enable you to have a fallback system if your project stops working or there's a problem tomorrow. The second problem is that if you can't do it with conventional code, you might want to look at open source to see if there aren't templates that already do what you want. Today, there are many models that are already very efficient, so test them to save time. On the other hand, beware of licensing. We'll be doing dedicated episodes on open source licensing. And then, in your companies, there will often be the question of, should I make, i.e. build my application, or should I buy, i.e. call on an existing service offered by a partner? And here, the answer is not so simple. It depends on 2 criteria. Firstly, the time to market, i.e. the time it will take to put your application into production for the first time. And secondly, the cost of your project. What's going to happen is that, for example, if we take our driver's license reading project, we could use the services offered by Microsoft Azure Document Intelligence, for example, which very quickly delivers very high performance in reading any type of document with a very good time to market. What's going to happen, however, is that this service has a cost. Well, I don't know the cost, but imagine it's 0 or 2 cents a prediction. That's fine if you don't have many predictions for your project. On the other hand, if you have 10,000 predictions a day, maybe the cost will be too high, and it might be more interesting for you to do a custom project in-house to drastically reduce prediction costs in production. In fact, it's all a question of time to market versus project cost. Maybe it's a good idea to start out with something that's already been purchased and then branch out into something that's made to measure little by little. These are strategic business choices. Let's return to our project. We've now reached the training phase, and we're going to ask ourselves the question, which algorithm should we use? If we look at our documents, we realize that we have cats and dogs. We could try to do it in classic code, but we really have a number of cases which are unstructured images with an almost infinite number of cases as input. As a result, it's not suitable for simple machine learning. The code won't work. We're bound to fall into the deep learning category. So, we'll have to ask ourselves, should I make or should I buy? It's a good question, but today, on our project, we have to make 10,000 predictions a day. Imagine that we buy a service that exists on the internet and costs 0.2 euro cents per prediction. In that case, if we multiply 2 euro cents by 10,000, we end up at 200 euros a day. This means that if we multiply by 30 days, the cost of our cat and dog classification project will be around 6,000 euros per month. This means the cost is quite high. And knowing that if we make this application and host it internally at MLOps Python, the cost of prediction will be 10 times less. 0.2 euro cents. If multiplied by 10,000, we're looking at 20 euros a day. Multiplied by 30, we're looking at 600 euros per month, which is still much cheaper than 6,000 euros. So, of course, it's less expensive and it's going to steal the cost of building a customized AI for our project. And that's it for this episode. We didn't lay the groundwork before diving headlong into a project. Really, it's very important to establish the baseline from which your project is useful. And before diving headlong into a technical solution, ask yourself the questions: what's the best technical solution for my project? Thank you and see you soon for more videos.